Good morning. Today our new class is requisites of oscillator and the second one is basic oscillator feedback circuit. Basic oscillator feedback circuit. These two topics are discussing one by one now. Okay. So next recap of this presentation. In previous class we discussed about advantages of negative feedback, applications of negative and positive feedback, oscillator and classification of oscillators and Barkhausen criterion. So these topics are completed in previous class. Okay. Next, objectives of this presentation. On completion of this period, you would be able to understand requisites of an oscillator and basic oscillator feedback circuit and summary. Okay. So first of all, we can start requisites of an oscillator. Requisites of an oscillator. The following are the requirements of an oscillator circuit. The following are the requirements of an oscillator circuit is, first one is there must be positive feedback. There must be positive feedback. And second one is initial loop gain AB. Initial loop gain A beta must be greater than unity. That is A beta is greater than 1. It is not B, it is beta. Okay. So initial the loop gain A beta must be greater than unity. That is nothing but A beta is greater than 1. And third requirement of oscillator circuit is nothing but after desired level is reached, the loop gain A beta must decrease to unity. So after desired level is reached, the loop gain A beta must decrease to unity. So these are the main requisites or requirements of an oscillator circuit. Okay. See this figure. This is the requirements of an oscillator. So these requirements of an oscillator circuit consisting of one tank circuit. Tank circuit means it consists of inductor and capacitor, both are connected in parallel. Okay. One tank circuit, one transistor amplifier and one feedback resistor. Okay. So the main requirements of an oscillator circuit is one tank circuit, one transistor amplifier, one feedback circuit. So what is the purpose of tank circuit in this figure? So observe this. It consists of inductor. L is inductor, C is capacitor. It consists of inductor connected in parallel with capacitor C. It consists of inductor connected in parallel with capacitor C. Observe this. The frequency of oscillations in the circuit depends upon the values of inductance L and capacitance C. So, in case of RC oscillators, inductor replaced by resistor. In place of RC oscillator, inductor replaced by resistor. I repeat once again this point. The frequency of oscillations in the circuit depends upon the values of inductance L and capacitance C. So in case of RC oscillators, inductor is replaced by resistor R. So here the second block is nothing but transistor amplifier. What is the functioning of transistor amplifier? Why it is connected in this circuit? Transistor amplifier function is to amplify the oscillations produced by the tank circuit. The output of the transistor can be supplied to the tank circuit to meet the losses. The output of the transistor can be supplied to the tank circuit to meet the losses. Okay, this is nothing but transistor amplifier. And next, third block is nothing but feedback circuit. And next third block is nothing but feedback circuit. What is the purpose of feedback circuit? Why it is connected in feedback circuit in this requisites of an oscillator? The feedback circuit, it supplies a part of output energy to the LC tank circuit. It supplies a part of output energy to the tank circuit in correct phase. That is, it provides feedback in addition to this Barkhasan criteria. It provides feedback in addition to this Barkhasan criteria, has to satisfy to get sustained oscillations, okay. So this is nothing but the figure of requisites of or requirements of an oscillator, okay. So tank circuit, transistor amplifier, feedback circuit also completed, okay. Next, this topic is completed. And next topic is basic oscillator feedback circuit. A circuit which produces oscillations of any desired frequency. A circuit which produces oscillations of any desired frequency is known as oscillatory circuit or tank circuit. What is the definition of tank circuit or oscillatory circuit? A circuit which produces oscillations of any desired frequency is known as an oscillatory circuit or tank circuit. So observe this. A simple oscillatory circuit consists of capacitor and inductance coil. Capacitor C and inductance coil L. Both are connected in parallel. See this figure. This is a figure of basic oscillator feedback circuit. It is a simple oscillatory circuit. It consists of capacitor C and inductance coil L in parallel. Okay. Observe this figure. Observe this basic oscillator feedback circuit. So this electrical system can produce oscillations of frequency. So these oscillations of frequencies are determined by the values of inductance L and capacitance C. So here capacitor C stores energy. First of all, capacitor C in this figure, observe this figure A. Capacitor C stores energy in the form of an electrostatic field. Capacitor C stores energy in the form of an electrostatic field and which produces a potential that is static voltage across the plates. While inductive coil stores its energy in the form of electromagnetic field. Observe this figure A. It consists of capacitor and inductance coil. Here capacitor stores energy in the form of electrostatic field, but inductor coil stores energy in the form of electromagnetic field. Okay. So here the capacitor, first of all, the capacitor is charged up to DC supply voltage when DC supply is applied. Here the capacitor is charged up to the DC supply voltage when DC supply is applied. When DC supply is applied, the capacitor is charged up to DC supply voltage. Figure A. Observe this figure A. In the position shown in figure A, the upper plate of capacitor. Observe this capacitor. Capacitor has two plates. Upper plate is positive, lower plate is negative. Here, the upper plate of capacitor has deficit of electrons. The upper plate of capacitor has deficit of electrons and the lower plate of capacitor has excess of electrons and the lower plate of capacitor has excess of electrons. Upper plate of capacitor has deficit of electrons and lower plate of capacitor has excess of electrons. Therefore there is a voltage across the capacitor. And the capacitor has electrostatic energy energy, and the capacitor has electrostatic energy. Okay, next, second point, when switch is closed as shown in figure B. Observe this figure B. So observe this figure A, switch is open, but observe this figure B. When switch is closed as shown in figure B, here when switch is closed, the capacitor will discharge through inductance or inductive coil. Okay, when switch is closed, the capacitor will discharge through inductance. The electron flow will be in the direction indicated by the arrow. Observe this, electron flow will be in the direction indicated by the arrow. So this current flow sets up magnetic field around. So because inductance stores energy in the form of electromagnetic field, that's why the current flow sets up magnetic field around the coil. Due to the inductive effect, current build up slowly towards a maximum value. So due to the inductive effect, the current builds up slowly towards a maximum value. Okay, the circuit current will be maximum when the capacitor is fully discharged. So when will circuit current will be maximum? The circuit current will be maximum when the capacitor is fully discharged. There is no charge in the capacitor. Okay, at this instant electrostatic energy is zero, because capacitor total energy is discharged to inductance coil is charge, energy is stored in the form of electromagnetic field. Okay, that's why at this instant electrostatic energy is zero at the capacitor, but because electron motion is greatest, that is maximum current, the magnetic field energy around the coil is maximum. So in this figure, observe this carefully. Obviously the electrostatic energy across the capacitor is completely converted into magnetic field energy around the coil. Observe this figure. So obviously the electrostatic energy across the capacitor, is completely converted into the magnetic field energy around the coil. Okay, so once capacitor is discharged, the magnetic field will begin to collapse. Once the capacitor is discharged, the magnetic field will begin to collapse and produce a constant EMF, electromagnetic field. Okay, so according to Lenz's law, the current EMF will keep the current flowing. Sorry, I repeat once. According to Lenz's law, the counter EMF will keep the current flowing in the same direction. So according to Lenz's law, the counter EMF, see this, observe this arrow indication here also, then arrow indication here also. Observe this inductance coil of figure B. Capacitor is discharged, total energy stored in the inductive coil, same direction. So but in this way, so according to the Lenz's law, the counter EMF, observe this opposite direction, the counter EMF will keep the current flowing in the same direction. So the resultant that the capacitor is now charged, with opposite polarity. So making upper plate of capacitor is negative. So because same direction, the resultant is that capacitor is now charged with opposite polarity. Opposite polarity means capacitor plates are changes, positive is negative, negative is positive. That's why, so the capacitor is now charged with opposite polarity, making upper plate is upper plate of capacitor is negative and lower plate of capacitor is positive, as shown in figure C. Observe this figure C. Figure C compared to figure A. So both are inversely proportional. Observe this capacitor. Here positive is going to negative and negative is going to positive. Negative plate is going to positive plate and negative plate is going to positive plate. After the collapsing field has recharged the capacitor. After the collapsing field has recharged the capacitor. Capacitor now begins to discharge. Capacitor now begins to discharge. Current now flowing in the opposite direction. Current now flowing in the opposite direction as shown in figure D, as shown in figure D. Figure D shows capacitor fully discharged. Capacitor fully discharged. Maximum current flowing. Okay. So the sequence of charge and discharge results in alternating motion of electrons or an oscillating current. Alternating motion of an electrons or an oscillator current. Okay. The energy is alternately stored in the electric field of the capacitor and magnetic field of the inductance coil. The interchange of energy between inductance and capacitance is repeated over and again, resultant in the production of oscillations. I repeat this point again. The sequence of charge and discharge results in alternating motion of electrons or an oscillating current. The energy is alternately stored. The energy is alternately stored in the electric field of the capacitor. The energy is alternately stored in the electric field of the capacitor C and magnetic field of the inductance coil L. This interchange of energy between inductance and inductance coil and capacitor, that means L and C, is repeated over and again, resulting in the production of oscillations. Okay. So this topic is completed. Observe this one by one points. 1, 2, 3 and 4. So 4 figures are there. Next, frequency of oscillations. The frequency of oscillations in the tank circuit is determined by the constants of the circuit L and C. The actual frequency of oscillations is the resonant frequency of the tank circuit and is given by Fr is equal 1 by 2 pi root LC. I repeat this point again. Frequency of oscillations. The frequency of oscillations in the tank circuit is determined by the constants of circuit L and C. The actual frequency of oscillations is the resonant frequency of the tank circuit. Then it is given by resonant frequency Fr is equal 1 by 2 pi root LC. Here in this equation where Fr is equal resonant frequency. So that is nothing but frequency of oscillations. Fr is equal resonant frequency, that is nothing but frequency of oscillations. So where L is inductance and C is capacitance. Okay. So the today topics are completed. And next, summary of this presentation, we have seen requisites of an oscillator or requirements of an oscillator, and second topic is basic oscillator feedback circuit. Okay. And next, frequently asked questions may be asked in today topics. The first question is explain about requisites of an oscillator. This question may also be asked on explain about requirements of an oscillator. And second question may also be, another question may also be asked in today topics is explain the operation of basic oscillator feedback circuit. So in this topic, so and another question may also be asked. Draw the circuit of basic oscillator feedback circuit. Draw the circuit of basic oscillator feedback circuit and also write down the equation of resonant frequency. And also write down the equation of resonant frequency. So different type of questions may be asked in today topics. Okay, today topics are very important topics. Prepare well. Okay. Okay, thank you.